Okay, looks like we are live.
Great. Welcome, everyone. It's 1 o'clock p.m. on June 9, 2021. This is the Hawaii Invasive Species Council meeting. Thank you for joining us. Special welcome to Grace Simmons, who's the Department of Health designee. And the first up on the agenda is the approval of the minutes from the January 27, 2021 meeting. Are there any comments, council members, on the minutes? Is there any public testimony on it? If not, is there a motion to approve the minutes of January 27, 2021?
Chair Case, this is Phyllis. I move to approve the minutes.
Thank you very much. Is there a second?
Second, Nick Comerford.
Thank you. All right, all in favor say aye. Aye.
Aye.
And please raise your hand, and I'm just going to run through the names for the record. So that's Case, Rodriguez from DOT, Comerford, Shimabukuro Geyser. Ms. Simmons was not there. I think that's, if you were at the meeting and approved the minutes, raise your hand and I'll do a roll call. Okay, Mary Alice Evans. Okay, that's approved. Thank you very much. Okay, first up on the regular agenda is item 4 on the agenda, submittal requesting approval of HISC Resources Working Group members.
Yeah, thank you, Chair and Aloha Council members, legislators, and federal partners. My name is Chelsea Arnott, and I'm the planner for the Hawaii Invasive Species Council. I'd like to mention before I get started on the submittal, the other program support staff that's here on the call today. We have Randy Bartlett, the HISC Interagency Coordinator, and Layla Kaufman, the Project Coordinator with the Mamalu Poipoi Airport Biosecurity Program. So they'll be helping us out today. So moving into the submittal requesting approval of the HISC Resources Working Group members, I want to start with just giving a quick background on the HISC funding process. Since its inception in 2003, the Hawaii Invasive Species Council has dispersed funding to support interagency invasive species project that one, fill gaps between agency mandates or existing agency programs, and or advance our collective knowledge through research and development of new tools. The HISC funds are dispersed through an intergovernmental granting process where the state, county, and federal offices may submit requests for funding and to meet collaboratively to draft a recommended budget for HISC review. The HISC Resources Working Group serves as the evaluation committee for that yearly HISC funding process, which develops the recommended budget for council approval. Members of the Resources Working Group are asked to evaluate and score proposals related to their sector or expertise. So that's anything from agriculture, natural resources, just a variety of sectors and expertise is needed. The scoring is then discussed at a meeting where applicants are encouraged to attend and answer any questions from the evaluators. A recommended award amount is assigned to each proposal based on the discussion and scoring. And that recommended budget is then presented to the council for approval. And usually those meetings are in late August, which I'm sure most of you remember those. So the Resources Working Group, sorry about that. Let me move forward. There we go. The Resources Working Group, it's comprised of representatives from the state departments here represented on the council, chairs from the HISC working groups, and HISC program support staff. We had recent discussions with the Office of Information Practices. We were discussing our newly formed HISC working groups and also the Resources Working Group. And after those discussions, it was determined that the Resources Working Group should be subject to Sunshine Law requirements, since this group is developing a yearly budget recommendation on behalf of the council. So to formalize our resources working group, we are requesting approval of the list of members provided here as the HISC Resources Working Group. And please excuse me just droning on, but I want to read out each of the members we're recommending. Justine Nihipali from the Department of Business and Economic Development and Tourism, Grace Simmons, Department of Health, Darcio Ishii, Department of Agriculture, Janice Matsunaga, Department of Agriculture, Masatomo Murata, Department of Transportation, Robert Hoff, Department of Land and Natural Resources, DLNR, Division of Forestry and Wildlife, Natalie Dunn, DLNR, Division of Aquatic Resources, Kim Fuller, DLNR, Division of Aquatic Resources, Mike Melzer from the University of Hawaii College of Tropical Agriculture and Human Resources, Christy Martin with the University of Hawaii Pacific Cooperative Studies Unit, Coordinating Group on Alien Pest Species, and also HISC program support staff. We provide the council with the following recommendation: that the HISC approve the recommended members of the HISC Resources Working Group to evaluate HISC funding applications and prepare the recommended budget, and that if there are any additional actions related to identifying and/or securing resources for invasive species work, the Resources Working Group could be utilized to assist that effort with HISC program support staff direction. And that if there are any changes to members of the HISC Resources Working Group, the council designates HISC program support staff to approve those changes. With that, I can turn it back over to you, Chair Case.
Thank you. That looks like a good list of people. Council members, any questions or comments about this list? Seeing none. And is there any public testimony on this? Right, hearing none. Is there a motion to approve staff's recommendation on this resources working group?
So moved.
Thank you. Is there a second?
I'll second Phyllis.
Thank you. All right, Evans and Shimabukuro-Geyser. All in favor, say aye. And again, please raise your hand so I can see your
Aye.
vote.
Aye.
Aye is Case, Rodriguez, Comerford, Shimabukuro-Geyser, Simmons, Evans, Lowen, aloha, Rep.
I'm not a voting member of this group, or correct? Is that right?
I don't know. I'd have to double check.
Okay.
Sorry,
In the
who
event
was-
that I am, sure. But I don't think I am.
Okay.
Yeah, it's, sorry, Chair, just to let legislative members know, you're not voting members, but you are welcome to ask questions and participate in discussion with any of the submittals or topics at the meeting.
Okay, we will note the support of the legislators for the action. Thank you all very much. That passes. All right, next up on the agenda is item 5, a presentation on the coordinated efforts of the Biocontrol Working Group in the planning, construction, and operation of the Pacific Regional Biocontrol Facilities by HDOA UH, USDA Forest Service, and USDA AARS.
Yeah,
Please
mahalo for that.
proceed.
Yeah, this is the longest title I think I've had for a presentation, but it's very fitting to what we're going to discuss today. So to get started with this presentation, I want to provide a little bit of background before moving into our presenters and also our submittal, which relates to this topic. So to start us off, I just want to clarify that we're talking about classical biological control. And for this meeting going forward, it will be referred to as biocontrol. And biocontrol is the selection and introduction of a natural enemy of an invasive plant or insect pest, which suppresses that pest in its home range. This is a cost-effective and sustainable tool that has been successfully employed across the globe for long-term management of some of the world's worst pests and weeds. Biocontrol is often the only viable option for reducing the impacts of invasive species that have spread beyond the ability to physically control them. And Hawaii has a long history of working together to safely and effectively use biocontrol to reduce pest populations and their impacts. Hawaii also is at the forefront of understanding potential unintended impacts of biocontrol on native species and other economically important species, and has worked successfully to avoid such risks in the last 50 years. Despite the success and achievements of Hawaii's biocontrol researchers and programs, our capacity has not kept pace with the introduction and spread of invasive species in recent decades. Land managers and agricultural specialists in Hawaii have identified many dozens of invasive species as targets for biocontrol, but inadequate greenhouse capacity and limited space for expansion are preventing needed and possible work on some of the most important pests. Furthermore, the two main facilities for biocontrol research, Hawaii Department of Agriculture in Honolulu and the US Department of Agriculture Forest Service on the island of Hawaii, are limited by design constraints and cannot handle the smallest of insect biocontrol agents or hold pathogens that could offer the best solutions to managing some of the worst pests. The US Forest Service facility in Volcanoes is also located near Kilauea volcano that has its risks and challenges, as we all know, with the recent eruption that impacted access and closed area roads. The need for improving biocontrol capacity in Hawaii and the Pacific region was identified as a biosecurity priority. Our Hawaii Interagency Biosecurity Plan, that was a gap analysis and provides a 10-year shared path forward, identified the need for new and federal biocontrol laboratories capable of serving regional biocontrol needs, as well as increasing biocontrol staffing and operational funding. In 2018, Governor Ige emphasized this priority as chair of the Western Governors Association, launching his initiative on biosecurity and invasive species. One of the agreed upon goals is protecting the West from the introduction of new invasive species through enhanced biosecurity practices, preparedness, and planning. State and federal agencies should develop state and regional level biosecurity plans and utilize new and emerging biosecurity technologies. A regional biocontrol research center should be established, and interagency collaboration on biocontrol research, permitting, and utilization should be improved and streamlined. The 2019 WGA special report further highlights the need for capacity building for biocontrol, outlining 4 key actions: enhancing regional biocontrol coordination, creating a regional biocontrol research center, establishing an interagency working group to improve coordination and increase information exchange for biocontrol research, permitting and utilization, and pooling research funding. State and federal partners came together to form the Biocontrol Working Group in 2018 to fulfill one of those key actions above and to help move this priority forward with consistent communication amongst state and federal partners and policymakers, and also coordination to pursue funding assistance. Recently, DLNR and the Coordinating Group on Alien Pest Species submitted an FY21 federal appropriations request for funding to carry out a feasibility assessment. For FY22, both agencies submitted appropriation requests for planning and construction funds. Okay. So moving into our presentations, we have a few of our members from the Biocontrol Working Group with us today to present on their agency's role in biocontrol work in Hawaii. I'll give a brief introduction for all 4 of our speakers and then lead in with a recorded presentation from our first speaker. So our first presenter will be Mark Wright. He's a professor of entomology at the University of Hawaii at Manoa, the College of Tropical Agriculture and Human Resources. His research program focuses on identifying environmentally sound pest management options with a special focus on biological control. Mark is currently doing research in South Africa, so he has sent us a recording of his presentation that I'll start in just a minute. Our next presenter will be Tracy Johnson, who is a research entomologist with the US Forest Service Pacific Southwest Research Station. His research focuses on biological control of weeds in natural areas, insect ecology, post-release monitoring of biocontrol agents, non-target impacts of biocontrol, and plant herbivore enemy interactions. And he is based out of a volcano facility on Hawaii Island. Next will be Darcy Oishi. He is the biological control section chief for the Hawaii Department of Agriculture and is also the current acting manager for the plant pest control branch in Honolulu. His position identifies and implements pest management options to protect agriculture with a focus on research, release, and monitoring of biological controls. Our last speaker will be Nicholas Manukas. He is a research biologist with the USDA Agricultural Research Services based out of the Daniel K. Inouye U.S. Pacific Basin Agricultural Research Center, or PBARC. His current research focuses on ecology and behavior of fruit flies and other invasive tropical pests that are threats to U.S. agriculture. And I just want to mention, we also have Rob Hoff, the protection forester with DLNR, Division of Forestry and Wildlife, with us today. He's not presenting, but he'll be available to answer questions. And I would like to ask the chair to allow time for questions at the end of all 4 presentations. So with that, I am just going to get out of our PowerPoint and let me just switch over to Mark's presentation here. And I know sound can be tricky on Zoom, so just let me know if it's not loading or you can't hear it.
Good afternoon, and thank you for the opportunity to talk about the University of Hawaii Biological Control Research contributions. I'm Mark Wright, entomologist with the Department of Plant and Environmental Protection Sciences at CETA, University of Hawaii at Manoa. So historically, University of Hawaii has played a role in biological control research in Hawaii, but we've had very limited access to quarantine facilities simply owing to the cramped space available, and that was typically very full, and it's difficult to allocate our space. We also typically were not considered an exploration partner, so we didn't participate in going and looking for biocontrol agents and bringing them back. That was essentially the Department of Agriculture's role, with a few exceptions. Mostly then we worked on monitoring biocontrol agents after they were released. We've done a fair amount of work on conservation biocontrol, in other words, encouraging resident natural enemies of pests to be more effective in certain circumstances. I've done a bit of work on augmentative biocontrol, so mass rearing, again, parasitoids that occur here already and releasing those, and then of course pest surveys and so on. Also, we contribute to assisting with the hire of staff for the quarantine facility at the Hawaii Department of Ag for some of our collaborative projects. And we do a fair amount of extension, for example, making people aware of the role of biological control agents like predators and parasitoids, as you see there on the left. We do have a fair amount of collaborative work between University of Hawaii and Hawaii Department of Agriculture. Down below here, you can see an example of a recent publication, which was in collaboration with Hawaii Department of Ag on erythrina gall wasp biological control. In that particular case, we did contribute to exploration work. There have been a few others, fruit fly parasitoids, aphid parasitoids, for example, where my retired colleague Russell Messing, for example, would contribute to exploration. Russ Messing would also hire postdocs and students to conduct quarantine work, and they would work in the quarantine when that was practical. In some other cases, there's a group of insects, the aphids, which are all invasive in Hawaii. There are no native species, and they're exempt from state quarantine, and we're allowed to conduct work on those for biological control in the UH insect containment facilities, which are tiny and inadequate for other biological control work. Currently, we're involved in some classical biocontrol research, which is collaborative work between us, University of Hawaii, the USDA Agricultural Research Service, And in this case, we had hired a postdoc who was conducting work on coffee berry borer parasitoids, which we were hoping to introduce using the non-target screening in the volcano quarantine facility. And this, of course, depends on effective collaboration with the Forest Service over in Volcano. Another big contribution we make here is working on native species like this little beetle shown in the image here to the top right, which can be used for that non-target screening. So we not only conduct the non-target screening, but also work on finding species to screen for non-target impacts potentially. The real constraints, though, on our being able to participate substantially in biological control from start to end of projects is inadequate space in the current Hawaii Department of Agriculture quarantine. There's simply inadequate room in that facility to do. It's already full, so we just don't have space to fit in there. We have a very small insect containment facility on our campus. It's used mainly for coconut rhinoceros beetle containment currently, but it's not suitable for biological control introductions. This all makes it impractical for us to have grad students and postdocs in many cases to work on classical biocontrol projects from when they start until they end, which could all be resolved by us developing new biological control containment facilities. We can contribute extensively to this work through our research faculty, through the flexibility we have in hiring postdocs. We can hire students to do elements of projects. We can hire technicians, and they can be sent to work in this facility. And ultimately, we can produce really good collaborative outcomes if we have these sort of facilities, particularly with Hawaii Department of Ag and with the Agricultural Research Services, Agricultural Research Service, and other organizations, of course. So I would strongly support the development of these new facilities. They would make a huge impact on our ability to conduct biocontrol in Hawaii and the Pacific effectively. Thank you.
Okay, let me get out of this. And so our next speaker will be Tracy Johnson. Tracy, I made you a co-host, so you're welcome to share your screen, or I can also pull up your PowerPoint.
Okay, I'll go ahead and try to share.
Oh, let me, yeah, there you go.
Is that visible?
That looks good.
Okay, it's skipped a slide. Okay. Yeah, so our Forest Service program is focused on biological control of plants, invasive plants in Hawaii and other Pacific Islands. And our program encompasses all the stages of biocontrol research, from selecting targets to exploring in the foreign countries where the weeds come from for natural enemies, bringing the natural enemies for quarantine testing, and then finally releasing and monitoring the impacts of the natural enemies. And so this process, it's very typically takes many, many years. 10 or more years is typical. And so we have a lot of projects kind of ongoing at all these different stages. And so our quarantine testing is what takes place in the containment facilities here in Hawaii that we're talking about. Our recent program has had a strong emphasis on biocontrol of mellostomes. They're a great target for Hawaii because we don't have any native mellostomes, and we have a lot of serious weeds in this family. So I've been working on a great diversity of natural enemies, and we have several of these that are ready to propose for release. Our quarantine facility We've had it since the mid 1980s, and it's been good for testing a lot of the insects that we have. But others kind of push the boundaries of our capabilities. So one example is a Myconia butterfly that we had to cage off a big part of the room, and because the butterflies need a lot of room to fly. And they didn't quite do perfectly in here. We were able to do the research in the end, but this definitely pushed the boundaries in terms of the small size of the space that we had. And there are some other natural enemies that I'm got in the pipeline now that are going to push the boundaries even further. So we're growing some big Myconia plants in pots for a natural enemy that uses the flowers of Myconia. So we have to have trees that are big enough to be reproductive, and then we have to take them into quarantine, keep them alive in there. So this one, I think we're going to be able to do it. It's definitely a big challenge, but this little wasp that lays its eggs in flowers and then it galls the fruit could be a really good addition to our toolkit for managing Myconia. And then Myconia is a pretty big tree, but Albizia, that's even bigger. So I'm really not sure how we're going to do everything we want to do with Albizia, but that's another one of our projects that's ongoing. And then one other type of natural enemy that's especially challenging is these microscopic things, really tiny arthropods or fungi or nematodes, things that are really small. We currently don't have any facilities in the state that can contain them. And yet we have some very promising natural enemies for some of our most serious weeds like Myconia, Glidemia, Albizia. So these are some that I would really love to be able to work on. I've been trying to develop as much information as we can outside of Hawaii first, but at some point, typically we need to bring things into the state and contain them in the state. So yeah, the small and the tall are my challenges. But I'll leave it at that.
Great, thank you, Tracy. Next speaker is going to be Darcy from Department of Agriculture.
Sorry, I forgot to unmute myself and then I confused myself with all the windows. Darcy Oishi, Hawaii Department of Agriculture. So first, to kind of highlight, like Tracy and the Forest Service, Hawaii Department of Agriculture also does what I'll call full service biocontrol, startup project all the way to completion point. How we're a little different from Tracy is Tracy's focus is forest weeds. Hawaii Department of Agriculture will focus on everything. So we do not only weeds, but we also do insect biocontrol. And I hope for the day where one day we can use techniques and technology to target diseases also as a target for biocontrol that are impacting our natural environment or our agriculture. And our program goes back all the way to Kingdom days. The biocontrol program really had its start when King Kalakaua decided to protect the coffee industry from black twig borer. And the first entomologist was brought on board then to work on that project. I'm going to focus, like Tracy, on facilities since the facilities are where we're unique and in trouble. Our facilities were built in the 1950s, so a bit older than Tracy's facilities. And we call this an open concept design, while the current residential real estate market seems to like open concept designs. This poses some problems when coming to our biocontrol work. As you can see in these pictures, we have these cages which represent either a replicant of an experiment or an entirely separate experiment in and of itself. So if there's a problem, we have zero containment between cages. And isolation is very good for some of our projects. We can focus on larger insect projects, whether the insect is a target or as a natural enemy. But as Tracy was alluding to, smaller projects like involving mites and thrips, for example, we can't work on in our facility. We do not have the design capabilities in the facility to address our minimum permitting requirements. The open concept design, as I alluded to, creates workflow issues, especially when we have a lack of space to house plants, which is what we have. And we have inadequate environmental control. So this space here, the center picture, is actually our attached greenhouse. And I have to emphasize attached. So what happens here in our greenhouse, which is where we keep all of our insects or plants that require more sunlight, this causes tremendous amounts of spikes in temperature and humidity throughout the whole facility. And this can really adversely affect our projects and also create seasonal issues with our projects. We also have support facilities that are not the best. So we have in bottom picture, we have our insectary, and our insectary have the same climate control issues and open design model that our containment facility has. It's built in the same era. One of our other significant issues is we do not have greenhouses to support any of our activities within the insectary or containment, whether that's insect containment or plant pathogen containment. And our plants must be maintained outside in cages. And sometimes we will partner with DLNR to supply our plants, but whenever we have it outdoors in uncontrolled environments, we're getting problems with aphids and other pest issues. And we spend a lot of time cleaning plants before they go into containment. And once they're in containment, we're spending a lot of time cleaning the plants also in order to keep, to remove the need to use pesticides, which can affect our experiments. Oh, I forgot, there's another picture. A key aspect for our biocontrol programs is our taxonomy program. So our taxonomists are used to identify all the potential natural enemies that we're identifying and characterizing while we're doing foreign exploration. So there's a literature portion where we're identifying potential control agents, and then we're going out in the field, observing the pest in its natural habitat and creating catalogs, conducting collections, and identifying what my program or Tracy's program could be using in the lab. Our big problem is the plant pathology facility, which has been problematic almost since day one. When we first completed the construction, we failed the commissioning portion by USDA. And a big portion of this issue was the building was designed from day one to be airtight. An airtight building creates problems when we actually need negative air pressure to contain things. So we went into a retrofitting to upgrade our air handling systems. And again, we barely met standards, and we were finally able to open in 1991. In 2011, we started looking at, well, in 2008, we were identifying repairs and fixes to the whole system, but the economic blip that happened in 2009 delayed that project to 2011. And unfortunately, we've not been able to meet the standards. So our pathology facility, we've not been able to bring in foreign agents to explore. And unlike, this was a unique function of Hawaii Department of Ag. We're the sole facility that was allowed to bring in foreign microorganism agents, which could include rust or nematodes, as Tracy was alluding to. As of 2021, we're continuing to identify problems with the facility. And so we really need a new facility to explore and fulfill our missions. What we're looking at is a containment facility with the ability to run 10 simultaneous projects in the same facility. Pathogens and insects would be contained in that same facility with different suites, which could include support for agencies like the Forest Service, and AARS. We'd also like the ability to meet level 3 containment standards, which is filtration of water and air into and out of the suites, and support facilities for work that is outside of containment, which would be greenhouses to support plants for rearing of biocontrol agents, climate-controlled insectaries, a bank of growth chambers for our pathogen work, diagnostic support facilities, and related work that includes testing and evaluation facilities, and to fulfill our vision. So that's all for my section. Thank you.
Thank you, Darcy. Our last presentation will be from Nicholas Manukas with the USDA ARS.
Thank you very much, and it's a real pleasure to be able to speak to you today. I'm going to give some highlights, mostly historical, but also a little bit of a flavor of what I think is possible in biological control in Hawaii. First, a quick introduction to ARS. For those who may not be familiar, we are the chief intramural research agency of the U.S. Department of Agriculture. We have locations nationwide, total of 2,000 PhD scientists and postdocs working here, total staff around 8,000. And as you can see, we have one location here in Hawaii, in Hilo. This is our research center, the Daniel K. Inouye PBARC, that's already been mentioned. My unit is one of three research units there, and we have 15 scientists on staff. This is a significant increase from when I started 10 years ago. We were 9 at that time, but we've been fortunate to receive new base funding each fiscal year the last 3 years with the appropriations. So we're growing. We also have 9 postdocs right now, also increasing that number. 12 permanent technicians, and a total size of about 45 people. I expect about 4 to 5 of these scientists to have significant work in biological control in the coming years. My unit focuses on invasive pest research for a lot of our work. That's biology, ecology, genomics, detection and mitigation. Traditionally, we've done a lot of that. Integrated pest management, and of course, relevant here, biocontrol and quarantine work. So I'm going to be speaking to you a little bit about fruit flies initially, some of the lessons we've learned from that, and then what I think might be possible down the line. So starting out with fruit flies, tephridids are serious economic pests. What they do is lay their eggs in fruit, as you see here. The larvae eclose, and they can produce extensive damage. Nobody wants fruit with maggots in them. So there are quarantine restrictions on these. It means that Hawaii has trouble exporting fruit, and it even causes problems on the mainland. If anybody's traveled to California, you know they x-ray your bags. It's mainly because of fruit flies. There can be quarantine treatments, but these are costly. And another aspect is that having populations of fruit flies established means that you have a reservoir to move these around the world. And this is an ongoing biological invasion problem. These things tend to hop around. So we know this story also. They're hopping around because there's a lot more movement. Here we have a chart up to 2017, visitor traffic to Hawaii. I apologize, the axes labels are reversed. But you can see that it's been increasing exponentially. And this is the story around the world. Basically more than half of the tephridid invasion and establishments that have been recorded have happened since 1990. And that's because of the movement of people. Here you see the four big pests that we have established here in Hawaii. Here they are in a little more detail and chronologically. The first to arrive and become established was the melon fly in 1895, followed by the Mediterranean fruit fly, 1910, Oriental fruit fly, 1945. This is the dominant fruit fly pest in a lot of the state. Malaysian fruit fly in 1983 looks very similar to Oriental fruit fly, but attacks different hosts a little bit. And most recently, the olive fly in 2019 was discovered on Maui and Hawaii Island. So the problem is certainly ongoing. USDA has been conducting research on fruit flies. This is the old fruit fly investigations lab, mid-20th century on Oahu for over 100 years. The first publication was in 1912. And a lot of that has involved biological control work. To give you some idea of how massive this was, there were 8, right early on, there were 8 parasitoids and 6 predators introduced just to deal with the melon fly establishment from 1895. And all these introductions happened between 1914 and 1950. There were 32 natural enemies introduced against Dorsalis, the Oriental fruit fly, over a 5-year span from 1947 to 1952. That is not a pace that we expect to replicate. It's probably not a good thing to do it at that kind of rate, but it sort of shows how active these groups were in trying to deal with the fruit fly problem. One of the very important species that was introduced is Phopius ericanus. This is an egg larval parasitoid. It's introduced to Hawaii about 1950, and it's been very successful. We've also have Dicasmomorpha longicaudata, some others, Biosteres, and these were all basically outcompeted by ericanus, which is a dominant parasitoid now in Hawaii. But the important point here is that ericanus is one of the most successful stories of introduction of biological control agent, certainly against fruit flies. And evidence of that success is that we were able to export it from Hawaii all around the Pacific and even further afield. So also longicaudata, but if you look at the A figure here, this gives the years and the destinations of exports of Phopius ericanus from Hawaii to other places. And I can add that since this figure was published in 2012, we've also sent this wasp to Senegal in West Africa and also to Brazil to deal with the fruit fly problem they have in the northern part of their country. So this has really been a big success story. What have we learned from all of this, from the fruit fly story? Well, the first is that, focus on infrastructure is critical. You've been hearing from the other speakers that we are lacking in some ways in terms of infrastructure in the state. You need it for many stages of the work, certainly for the quarantine and screening stage. It also takes time to make all these things work, even if you have the facilities. That's something we've learned. Rearing these insects or biological control agents is not a simple task. It requires development and investment. And of course, we've had situations of colony loss, and that can certainly set our program back. I also want to mention that measuring the outcome is essential. I'm not showing you any data on this. One of the best studies to show the impact of these introductions of biological control agents was done by my former colleague Roger Vargas when we exported Phopius ericanus to French Polynesia and made releases in several islands around there. And they measured and watched how the wasp was able to displace the fly in many different fruits. So we believe that is always a critical component of any biological control program. Even though I'm not showing it to you here, it is something that we do, and it's an important emphasis. Okay, so what are we doing today, and what can we be doing in the near future? Right now, we have a big focus on coffee berry borer. As Dr. Wright mentioned, we've been doing collaborative work with them on the Phimastacus coffea, which you see the paper here has just been published in collaboration with UH. This is work done at the Volcano facility. We're very interested in also predators as a kind of biological control for coffee berry borer. And then we continue to work on fruit fly issues and, of course, the olive fly. We've initiated collaboration with scientists at the European Biological Control Laboratory, which has a large quarantine facility in Montpellier, France. And they've been working for many years on biological control of olive fly. Primarily, they were targeting olive fly in California because it was established there about 20 years ago, and they have quite a large olive industry. So we'd like to learn from them and maybe see if we can expedite some improvements for our situation here in Hawaii. In the future, areas that we're targeting right now are the Queensland longhorn beetle. That's this character here in the photograph. This is a big problem for our fruit tree growers, kukui, various other culturally and economically important trees. The larvae, the grubs, bore into the tree and can kill it. And it turns out that their numbers can get pretty high here on our island. Where they come from in Australia, they are not a pest or a problem. So the biology of this beetle, longhorn beetle, is largely unknown. The reason it's not a problem in Queensland is probably because there's something that either parasitizes or eats it. So it'd be great to figure out what that is and start the long process of figuring out if that's something we want to bring over to Hawaii. The Macadamia felted coxid is another species of interest. We have a new researcher starting at PBARC this summer who will be focusing on macadamia issues, and I believe she could be working on biological control. Two-line spittlebug, a pest of pasture, is another one that we could be looking at. And then, of course, the recent problem with coffee leaf rust. This might require specialized facilities because that is a fungal pathogen, but it's something that we should look at perhaps as future biological control projects. Okay, I just want to acknowledge the Interagency Working Group, all of our forebears and ancestors in USDA and other collaborators, and thank you very much for your attention.
Yeah, thank you so much, Nick, and all the rest of our presenters. So that ends the presentation portion for this section of the agenda, and we can open it up with chair's approval to questions and discussion.
Thank you. Okay, questions from the commissioners first. Very thorough presentation. Obviously, we have a lot of outdated facilities and a need for capacity to hold large and very small items in this biocontrol process. So any questions from anyone? All right, we have no questions. So that's, I think, a good testament to the, I found it a very interesting set of presentations. Actually, really updated my knowledge of the whole universe of biocontrol work in Hawaii, of which I have seen a lot of pieces, but that was a very helpful kind of overall outline from different angles. So I think we can, Rep. Blowen has a question.
Sure. Just a quick question. Are you guys doing any work with little fire ant, or do you not want to cross wires with White Ant Lab?
Is this a question for ARS or?
Oh, I guess, well, I was thinking for you, but.
Yes.
Yeah.
So yes, we are doing a little bit of work in collaboration with ARS scientists in Florida on a hydrophobic ant bait. We also have a newer chemical ecologist in the unit, Dong Cha, who's been working on identifying trail pheromone for little fire ant, which would be very useful for disrupting them. So we have a little bit of work in that area. No biological control yet, though, on that topic. But that would certainly, living on Hawaii Island, I think that would be a worthy thing to look at for sure.
All right, thanks.
In the realm of,
you wanted to add something?
yes, in the realm of biological control, a fungus was examined. I believe it was 2005, and that was not found to be effective at all. We collaborate with the USDA ARS Gainesville laboratory, which has a significant amount of specialists in ants, and we've been looking at potential for biological control of little fire ant for the past 20 years, and there hasn't been anything promising that has been identified. You may have heard recently there was a parasitoid that has been identified impacting, well, I shouldn't say impacting, that was found in colonies on Hawaii Island. However, that species has a very cryptic biology and would not be suitable for a biological control project for little fire ant.
Yeah, thank you, Darcy. And just to follow up too, I did want to mention we do work with the Hawaii Ant Lab. They're of course partners on a lot of these issues, but we are hiring a social insect focused scientist in the coming year or two. And so we're hoping to have more of a presence on those kinds of pests.
Thank you. Other questions or public testimony on this presentation? Mr. Rodriguez. You're on mute.
I had a question about the Albizia mite gals. How promising is that?
So those mites, we found them in the native range in Indonesia and Papua New Guinea. And they do a good amount of damage. So if they were brought in without any of their own enemies, they could potentially have some significant impact on Albizia. But it's still really early days. We don't even have a scientific name for that mite yet. And as I said, it's too small for any of our facilities here in Hawaii. So we're going to try to collaborate with some New Zealanders who have good facilities. But Biocontrol obviously is an international partnership all around. So New Zealand and Australia are really key partners for Hawaii. And we're hoping to get help from them on this one.
Thank you very much.
Others, questions, comments? All right, hearing none, I think we can go on to item 6 on the agenda. You have a submittal on this.
Yes, I will share my screen so everybody can see that submittal. All right. So our submittal is requesting a resolution to support the planning, construction, and operation of the Pacific Regional Biological Control Facilities in Hawaii and committing agency engagement. And the presentations that we just gave serve as background for this resolution, and the actual resolution 21-1 is included in the meeting packet. For the recommendations for that is that the HISC adopt a resolution to substantially similar to the attached draft resolution in order to first recognize the need for new regional biological control research facilities to collaboratively conduct and develop safe and effective biocontrol agents for priority agricultural and environmental pests and weeds that threaten Hawaii and the Pacific region and the continental US. Second, recognize Hawaii's need for modern biocontrol facilities and additional researchers is a top priority in the Hawaii Interagency Biosecurity Plan and the Western Governors Association Initiative on Biosecurity and Invasive Species. And third, support the efforts of the Biocontrol Working Group to identify and pursue funding assistance towards planning and development of new state-of-the-art biological control facilities in Hawaii that can serve as a regional research center for biological control programs. And with that, I will turn it over to you, Chair.
Thank you. And council members, the wording of the resolution is attached in the packet. And there are whereases that reflect all of the discussion we've just had. Let me just read the 3 core paragraphs of the resolution. Be it resolved that the Hawaii Invasive Species Council recognizes the need for new regional biological control research. Are these in the submittal? Is that language in the submittal? Yeah.
Yeah, it's the same language, but
language. Okay. So we have the same language in both the submittal and in the draft resolution. So So let's just go to questions or comments from anyone. And maybe you could unshare screen because I can't see everyone when they raise their hand. David, are you still raising your hand, or is that from before? From before. Okay. Any other questions or comments? I am fairly confident that we all support this resolution solidly. So I'm not hearing any questions or comments. Is there any public testimony on this?
Yes, there is public testimony. I'll let Randy Bartlett take that over.
Yes, we have Christy Martin from CGAPS here to provide some oral testimony. Christy.
Aloha Council, thank you so much for hearing this. And thank you for considering this resolution and just learning more about biocontrol in general. It's been an honor to help support this effort. And I would love to see these facilities come to fruition. If I may, I have an opportunity, but we need your help for it. The Western Governors Association meeting is coming up at the end of June to the beginning of July, where Governor gets to meet with new Secretary Holland, as well as Department of Ag Secretary Vilsack. We've heard from our congressional delegation staff that we need to send a strong signal from Hawaii and other areas in the Pacific that we would like these facilities. And I would just like to suggest that this council consider briefing Governor about this, our progress made, as well as some questions he might want to pose or discuss with Secretary Vilsack, possibly as part of that WGA meeting. Mahalo.
Thank you for that.
Chair, we also have a late emailed written testimony from in support from Andy Cullison at DOFA. So just to let council know.
Thank you. Okay, any other questions, comments, testimony? All right, hearing none, somebody want to move to approve the resolution as submitted?
I move to approve. Sorry,
Okay.
Nick.
Phyllis, did you want to second it? Is that a second? So Nick moved, Phyllis second. Okay. Further discussion? If not, all in favor, say aye.
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 Aye. Okay, so you got to raise your hand so I can name everyone. Rodriguez, Case, Shimabukuro, Geyser, Comerford, Evans, and Simmons as the voting members of the commission, which I'm sure reflect the broader sentiments of the members and the participants here. Okay, that passes. Thank you very much for your work on that, and we will definitely follow up with the governor and the Western Governors Association on this topic. All right, I think we're in the public comment period. So do we have any public comments?
We have not received any public comments through the YouTube feed or prior to the meeting.
All right, well, that brings us to the end of our agenda. Council members, I thank you for your time and your attention and your commitment to the tackling the invasive species challenges in Hawaii. Is very, very critical, as we all know. And we really appreciate all of your support within your agencies, within the legislature, and within the nonprofit and federal and other arenas. So thank you very, very much. That brings us to the end of the meeting, and the meeting is adjourned at 2 p.m.
Thank you.
Thank you. Mahalo to the presenters.
Thank you, everyone.